Now we're looking at the sarcomeres, or the contractual units of the muscle, and the structural units of the myofibrils, and they form visible patterns within the myofibrils. A striped or striated pattern within the myofibrils. We've got a darkened thick filament called the A band and a light thin filament called the I band. You'll see I've used this example for you to label in your lab reports. The sarcomeres with the A band have an M line, which is the center of the A band, and an H line, which is around the M line. And then there is a zone of overlap. This is the darkest area where the thick and thin filaments overlap. Now within the sarcomere there's the I band, which has the Z lines, which is the center of the I bands and the two ends of the sarcomere. The titin are strands of protein which reach from the tips of the thick filaments to the Z line and help stabilize the filaments. So we'll look at that now. So here we're looking at one muscle cell fiber, and we're looking at how the contraction begins. So we've got a longitudinal section of a sarcomere showing the bands. So you've got the I bands, the A bands, the H band, the Z line with the thick and the thin filaments. And then you've got the zone of overlap, so where the thick filaments will be moving and the Z lines will be decreasing and increasing in strength to provide contraction. Not strength, length, to provide contraction. So here it is, so from a microscope view, magnified 64,000 times, and we've got those same bands, but looking a little harder to differentiate compared to the beautiful animated drawing. So here we are looking again from moving down from the skeletal muscle right down to the smallest unit of the sarcomere. So you've got the epimysin, which is the tough covering around the skeletal muscle, and then we move down to the smaller perimysin, which surrounds the bundle of muscle fibers. And then we've got the endomysin, which surrounds each single muscle fiber. And then within that, at the bottom of the picture, you can see that where we've got the myofibrils. And inside the myofibrils, they're surrounded by the sarcoplasmic reticulum, and that's where we have the zones that we're talking about, the I band, the A band, the Z line, and the M line, and the H band. So these are the areas where the muscle changes in length. So myosin action. During contraction, the myosin heads interact with the actin filaments, forming cross bridges, and this produces movement. The sliding filaments and muscle contraction. So this is based on the theory that the thin filaments of the sarcomere slide towards the M line across the thick filaments. The width of the A zone stays the same. It is the Z lines that move closer together. So here we have the A zone and the Z lines. So the A zone doesn't change, but the Z line changes in length. It gets shorter as the muscles contract, and it gets longer with muscle relaxation. During contraction, the A band stays the same width, but the Z lines move closer together and the I band gets smaller. When the ends of the myofibrils are free to move, the sarcomere shortens simultaneously, and the ends of the myofibrils are pulled towards the center, and the whole muscle shortens. So with skeletal muscle contraction, the process of contraction is determined by neural or nerve stimulation of the sarcolemma. It causes an excitation, contraction coupling. And the muscle fiber contraction is an interaction between the thick and the thin filaments, and tension is produced. So here we can see in the top part of the picture, in the purple area, the neural control. So that bit coming down, what looks like three sausages, is actually a nerve. and the nerve is spreading out across the surface of the sarcolemma, or the surface of the nerve cell. And each of those little bluish plates, if we look down at the excitation process, that one sort of oval is releasing chemical called acetylcholine, and it then is being taken up by the surface of the cell, and that triggers release of calcium, which in turn with energy causes a reaction with the thick and thin filaments. And that leads to muscle contraction, and it leads to tension production.